tail-to-head method to find the resultant vector. We have seen that a vector is represented by an arrow pointing in the direction of the vector. In grade 10, we shall consider vectors in a single dimension only. The rear end is the tail of the vector, and the end with the arrowhead is called the head of the vector. The tail-to-head method is one method of finding the resultant of many vectors. The second vector is moved such that the tail of the second vector is placed on the head of the first vector. Then the third vector is moved such that its tail is placed on the head of the second vector. This is continued until all vectors have been placed tail to head. Finally, the resultant vector is drawn from the free tail to the free head, that is, the tail of the first vector to the head of the last vector. Let us take an example to understand it better. Consider a box and 4 people engaged in a tug-of-war on a beach. The box is in the middle, with 2 people on either side, pulling the rope on their side towards themselves. On the left of the box, the forces vector F1 and F2 have magnitudes 5 Newton and 3 Newtons respectively. They are acting to the left. On the right of the box, the forces vector F3 and vector F4 have magnitudes 2 Newton and 7 Newton respectively. They are acting to the right. We assume that the direction to the right is the positive direction. The direction to the left is the negative direction. What would the resultant vector be? Which way would the box move? First we draw all the forces acting on the box. Then we simplify the diagram and rearrange the vectors. Remember that vectors can be freely moved about as long as we preserve the magnitude and direction. Using the tail-to-head method, we place the tail of vector F2 on the head of vector F1. We then place the tail of vector F3 on the head of vector F2. We then place the tail of the last vector F4 on the head of vector F3. The resultant vector is drawn from the free tail, that is, the tail of vector F1, to the free head, that is, the head of vector F4. We observe that the magnitude of the resultant vector Fr is 1 Newton, and it is in the positive direction. Vector Fr equals plus 1 Newton, equals 1 Newton to the right. So the box would move towards the right. This method is very useful to find the resultant vector in problems featuring multiple vectors.
Starting to feel it? Now go master it with Maski.